Good morning children. In today's class we are proceeding to exercise 8.1 problems based on midpoint. Let us recall section formula. P divides AB in the ratio m is to n. How to write the position vector of P? It is n into OA, the position vector of A, plus m into OB, the position vector of B, divided by the total, that is m plus n. Now the question is midpoint. Whenever I say P is a midpoint of AB, the ratio m is to n is becoming 1:1. Why? Because they are equal. P is a midpoint tells me AP and PB are equal in length. So now what is my answer? 1 into OA, 1 into OB. So what is OP vector? It is OA plus OB by 2. So let us remember, midpoint of the line segment has the position vector. Add the two vertices, divide by 2. OA plus OB by 2. Let us proceed into exercise based on midpoint. Exercise 8.1, question number 4. If D and E are the midpoints of the sides AB and AC of a triangle ABC, we need to prove that BE plus DC vector equals 3/2 BC vector. Given D the midpoint of AB. So how will I find out the position vector of D? Section formula gives us 1, 1. Whenever I say midpoint is 1:1. So I will write OA vector plus OB vector divided by 2. Similarly, E the midpoint of AC. So what is OE vector? It is 1:1. So OA plus OC by 2. Now we need to prove some result. Let us start from the LHS. I want BE vector plus DC vector. How to write this BE vector? Remember the idea, second minus first. So how to write BE? OE vector minus OB vector plus. How to write DC? Second minus first. OC vector minus OD vector. What is OE from here? I have OA plus OC by 2 minus OB plus OC minus. What is OD from here? It is OA plus OB by 2. Taking LCM, that is 2. I have OA vector plus OC vector, 2 into OB vector, 2 into OC vector, minus OA vector, minus OB vector. It is good that we put arrow mark like this for vector notation. If that is difficult, at least we must represent a line over. As I simplify, OA minus OA cancels. 2OC plus OC is 3OC vector. Minus 2OB minus OB is minus 3OB vector divided by 2. OC plus 2OC is 3OC, minus 2OB minus OB is minus 3OB. In both the terms, 3 is common, so I can write OC vector minus OB vector by 2. What formula is this? See, when I want BE, second minus first I write. So when I have OC minus OB, it is BC vector. So I will write 3/2 into BC vector, and that is the RHS of the problem. So we started with LHS and arrived at RHS. Question number 5. Prove that line segments joining the midpoints of two sides of a triangle is parallel to the third side whose length is half of the length of the third side. Let us consider D to be the midpoint of AB. So OD is OA plus OB by 2. And E to be the midpoint of AC. So OE vector, the position vector of E is OA plus OC by 2. Now we need to find this side, that is joining the midpoints. So I want to find out DE vector. What is DE vector? OE minus OD. Remember, second minus first. What is OE vector? OA plus OC by 2 minus. What is OD vector? OA plus OB by 2. Remember to put vector symbols as we are in the chapter Vector Algebra. Now I can rewrite this as by 2 OA plus OC minus OA minus OB. I want to show this is nothing but half of the third side. That is, I want to show it is half of BC vector. What is BC vector actually? It is OC minus OB. Here, plus OA minus OA cancels. I arrive at OC vector minus OB vector by 2. What is OC minus OB? Which is nothing but BC vector. So I started with DE vector, ended with half of BC vector. Hence, I will say DE goes in this direction, BC goes in the same direction. So we get DE is parallel to BC. Also, when I take modulus, mod DE is modulus of half BC, or it is DE, the length of it is half of BC, the length of it. Hence, I am able to show the length is half of the length of the third side. Hence the problem. Exercise 8.1, question number 6. Prove that the line segment joining the midpoints of the adjacent sides of a quadrilateral form a parallelogram. Consider ABCD to be a quadrilateral. What do you mean by a quadrilateral? A four-sided closed figure. The sides need not be equal or parallel of anything of that sort. Now the question is midpoints. Let me choose E, F, G, H to be the midpoint of each side. So we know the midpoint formula. OE is OA plus OB by 2. I can write OA, the position vector, as A vector, and OB, the position vector, as B, OC, the position vector, as C, and OD, the position vector, as D. Once we know the midpoint formula for each. What is the question? Line joining the midpoints E, F, F, G, G, H, H, E. This needs to be a parallelogram. So our condition is to show that EFGH is a parallelogram. Whenever I want to show a four-sided figure is a parallelogram, the basic condition is diagonals bisect each other. What are the diagonals of this parallelogram? EG and HF. EG and HF. So what I want to show is midpoint of HF and midpoint of EG are equal. Let us find out what is midpoint of HF. What is the formula for the midpoint? We know it is OH plus OF by 2. So what is OH vector? It is A plus D by 2 plus what is OF vector? It is B plus C by 2. The whole thing divided by 2. Or it is A plus D plus B plus C, the whole thing by 2 and the whole thing by 2. The LCM 2 and the denominator 2. I can combine. So my answer is A plus B plus C plus D. 2 2s are 4. So this I call midpoint of HF. So midpoint of HF is A plus B plus C plus D, the vectors divided by 4. Now I need to find out midpoint of EG vector. What is mid of EG? OE vector plus OG vector divided by 2. What is OE? From here, it is A plus B by 2. What is OG from here? C plus D by 2. The whole thing divided by 2. I can use the same argument and I can show mid of EG is A plus B plus C plus D. 2 2s are 4. The LCM 2 multiplied with the denominator gives us 4. Now I can show both are equal. So call it as number 1 and this result as number 2. 1, 2 implies mid of HF equals mid of EG. So I am able to show diagonals bisect each other and therefore EFGH is a parallelogram and hence the problem is proved. Question number 9. If D is the midpoint of the side BC of a triangle ABC, we need to prove that AB plus AC is twice AD. Now method 1. I can consider A is the origin of reference. When I consider A as the origin of reference, what is midpoint of BC? It is position vector of B plus position vector of C divided by 2. I have taken A to be the origin. So what is position vector of B? Origin, I have to consider AB. So it is AB vector. Position vector of C is AC vector divided by 2. And what is midpoint of BC? We have considered as D. So it is AD vector. So when I consider A to be the origin of reference and D the midpoint of BC, I can write AB plus AC by 2 is AD. Cross multiplying, I have shown twice AD vector is AB vector plus AC vector. We can also prove the same problem with some other method. How am I to prove it? What is LHS? It is AB vector plus AC vector. My question in the RHS is AD. So write AB in terms of AD. So how to write AB vector? It is AD vector plus DB vector. How to write AB vector? It is AD vector plus DB vector. Same way, how to write AC vector? I want AC. AD plus DC. So I will write it AD plus DC. Remember the idea of vectors. The Same letter cancels, I get AB. The same letter cancels, I get AC. Now my question is, AD plus AD is 2AD vector. These two, how am I to think? D is the midpoint of BC. Whenever D is the midpoint of BC, what do I understand? DB vector and DC vector. DB goes this way, DC goes this way. So they are equal but opposite in direction. Why? Because DB goes in this direction, DC goes in opposite direction. They are equal in length but opposite in direction. So wherever DB comes, I can very well write minus DC. Call it as result number 1. So DB vector, I am writing minus DC vector, and this I as usual write plus DC vector, and I use result number 1. As I substitute plus DC minus DC cancels, I just get 2AD vector, and that is the RHS. So when I started from LHS, I am able to arrive at RHS, and so AB plus AC equals twice AD. Now this is second method of proving. You can choose whichever you prefer. Question number 11. Let A, B and C be the vertices of a triangle. Let D, E, F be the midpoints of the sides BC, CA and AB respectively. We need to show that AD plus BE plus CF is equal to 0. As we know, if D, E, F are the midpoints of the sides, we need to write OD vector is OB plus OC by 2. OE vector is OC plus OA by 2. OF vector is OA plus OB by 2. Now let us start from LHS. AD, I need to write it as second minus first. BE, second letter E minus first letter B. CF, OF minus OC vector. We know what is OD. What is OD? It is OB plus OC by 2 minus OA vector. What is OE? OC plus OA by 2 minus OB vector. What is OF? OA plus OB by 2 minus OC vector. Let us take LCM as 2 for all the terms. I get already 2 is coming, so it is OB plus OC. Cross multiply 2 into OA plus already 2 is coming, right as it is. OC plus OA. 2 into OB plus already 2 is coming, right as it is. OA plus OB. 2 into OC. Now as I check, OB plus OB, 2OB vector. OC plus OC, 2OC vector. OA plus OA, 2OA vector. The remaining minus 2OA, minus 2OB, minus 2OC. The whole thing divided by 2 and the terms get cancelled. We arrive at 0 by 2, that is 0, which is the RHS. So these are simple problems based on the midpoint formula. Whenever D is the midpoint of BC, remember O the origin of reference. So OD vector is OB plus OC by 2. In the same way we have written. The next formula to remember is when I want AD vector, second minus first, use your position vector. So OD minus OA. Same way we have written the remaining. By taking LCM, we are able to show that the terms get mutually cancelled. And I arrive at 0 by 2, which is 0, and hence we have proved the problem. Question number 12. If ABCD is a quadrilateral and E and F are the midpoints of diagonals AC and BD respectively, we need to show that AB vector plus AD vector plus CB vector plus CD vector equals 4 into EF vector. When I know E, the midpoint of AC, AE and EC are same in direction. So I can say AE vector equals EC vector because E the midpoint of the diagonal AC. Similarly, F the midpoint of diagonal BD. I can say FB and DF are equal in direction, and F being the midpoint, I can say FB equals DF. Now let us go on to the LHS of the result that I need to show. I have AB vector. RHS is containing EF vector. Let me write AB using EF. How shall I write it? A to E, E to F, and F to B. See, we started from A, ended with B. A to E, E to F, F to B. In the same way, let me write AD vector. How to write AD vector? It is AE, EF, FD. So how shall I write it? AE, EF, FD. Now I want CB vector. CB vector. C to E, E to F, F to B. So for every vector I am introducing EF. So C to E, E to F, F to B. Remember to put the vector symbols. Similarly, what is CD vector? C to E, E to F, F to D vector. In all the cases, as I check, EF, 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 EF has come. How many times? 4 times. So as I add, it is 4 times EF vector, 2 times AE vector, 2 times FB vector, 2 times FD vector, and 2 times CE vector. We know instead of AE, I can write EC, or if I reverse, plus symbol will become minus. So 4EF twice AE I am writing minus 2CE. Similarly, FB vector I can write minus FD vector. So 2 as it is, instead of FB I write minus FD. Now see, the terms mutually get cancelled, just leaving us 4 into EF vector, and that is the RHS. So let me call this result as number 1 and let me quote it where I am using. So from result number 1, I can say FB is minus FD and AE is minus CE, and just by cancelling plus and minus terms, we are able to arrive at the RHS, that is 4 into EF.